Imagine a sprawling, hyper-modern fortress rising in India, built specifically to house thousands of the most advanced artificial intelligence microchips on the planet. This massive construction project represents a 10,000 to 15,000 crore rupee commitment. That is roughly 1.8 billion US dollars. The corporate giant executing this historic order is Larsen Toubro, or LNT. They secured the contract from Together AI, a major global provider of AI infrastructure. It might seem unusual for a heavy civil engineering company to take on a computing facility. However, the project is an AI factory, requiring more heavy construction than a standard office building. Artificial intelligence depends on massive amounts of concrete, steel, and electrical power. Building these facilities is rewriting India's technological landscape by turning digital code into physical infrastructure. To understand an AI factory, let's look at a traditional data center first. These are filled with standard central processing units that handle everyday tasks like loading web pages, checking email, and streaming video. Think of a standard data center as a large, multi-story public parking garage. Everyday data requests are like ordinary passenger cars. They drive in, park quietly in their spots, and eventually leave, requiring only basic concrete floors and normal air conditioning. The AI factory operates like a high-speed Formula One engine testing complex. Inside, thousands of linked processing units run at maximum capacity 24 hours a day to train massive artificial intelligence models. This activity generates heat so intense that standard ceiling fans or basic air conditioners would fail. The power demand is large enough that plugging the facility into a standard city power line would blow out the regional electrical transformers. To handle this load, the facility requires dedicated high-voltage power substations and specialized heavy structural engineering just to support the sheer weight of these dense server racks. Housing artificial intelligence is an extreme civil and mechanical engineering challenge that goes far beyond standard IT networking. The hardware driving this massive construction effort is Nvidia's next-generation B300 Blackwell graphics processing unit. These superchips have an incredibly dense power footprint. A single server rack packed with B300 chips can consume over 100 kilowatts of power, which is 30 times more than a traditional server rack. If you cannot keep these processors cool, they will reach dangerous temperatures and slow themselves down to prevent permanent damage. To solve this, L&T is building an advanced direct-to-chip liquid cooling system. Instead of blowing cold air, non-conductive liquid flows directly through microscopic copper plates on top of the silicon chips. It absorbs the heat and carries it to external coolers in a continuous cycle. To manage the electrical demand, L&T is using a power system designed like building blocks. These individual units work together to deliver a continuous, stable feed from renewable sources without stressing the local power grid. For decades, L&T has established itself by building enormous physical structures, like long-distance expressways, complex bridges, and vast metro railway systems. By mastering liquid cooling and distributing gigawatts of electrical power, L&T is evolving into a primary architect of the global artificial intelligence boom. Building an AI factory of this scale brings tangible economic benefits to India. It creates a wave of highly specialized, well-paying careers. The country will need domestic thermal cooling technicians, complex structural designers, and specialized power engineers to operate these facilities. Historically, if an Indian startup or university wanted to train a large artificial intelligence model, they had to rent expensive computing power, hosted in data centers across North America or Europe. Having an advanced AI factory physically located in India eliminates that delay. It keeps domestic data within the country's borders and significantly lowers the computing costs for local founders, building custom tools for our citizens. Constructing liquid-cooled, gigawatt-scale computing hubs proves that India possesses the industrial scale and the power engineering expertise required to build the physical backbone of the digital economy. Now that India is actively building gigawatt-scale AI superfactories, do you think our domestic startups will lead the next wave of global innovation, or will foreign tech giants maintain their dominance? Let me know your thoughts down in the comments.